Hello and welcome to another video. In this video we're going to be working on find the kth smallest pair distance. And in this one the distance of a pair of integers is defined as the absolute difference between a and b. Given an array nums and integer k, return the kth smallest distance among all the pairs nums I and nums j. So in this first example, the pairs you have is 1 and 1 is a pair, 3 and 1, and then this one over here. And you don't want duplicate pairs, so you don't want like 1 and 3 and then this same thing. So you want to have individual pairs. And so here's all the distances. So the smallest distance is 0. So that's what you want to return. In this, all the distances are 0, so you just return 0. And in this, you have this distance, and then this distance here. So it's going to be like 0, 5, 5. So the third smallest is 5. Okay, so this problem's pretty tough, and you can't do something like get all the pairs and get all the distances and sort them or use a heap, because these constraints are 10 to the 4th. But this type of problem I would actually recommend learning, and I'll show you like the best way to do it. And you can apply this to other types of problems. So this is you can apply this to any type of problem where you have distances or something you can calculate, but you don't have time to calculate every value, right? So like a multiplication table or like some big list, or not some big list, but like, you know, when you have all kinds of combinations, and then for those combinations you can quickly predict like, are they going to be bigger or smaller than something, but you can't actually get them all, right? So one example would be like, you know, instead of this addition, you have like a multiplication table where you can take like any one of these numbers and multiply by another one of these numbers. You can quickly grow and shrink your result, right? So you can have something like 2 pointers here, and you can say like, okay, well, if this is too small, I'll make it bigger. If it's too big, I'll make it smaller. And then you can quickly figure out like stuff like that. And so this is going to be similar to that. And there's like 10 problems that do this kind of thing. There's actually one that we did earlier. There was a medium problem in this month, but I did like a easier solution than this because it was a medium problem, but you can apply this to that as well with like a couple more steps. So the basic idea is we can't actually get all the pairs, so what else can we do? Well, instead of answering the question of like what's that pair, we can answer the question of given some distance, how many pairs have a distance less than or equal to that. So for example, let's just get some array of some stuff. So let's say, and we're going to have this sorted. So you're going to want to sort your numbers just because like you don't have very many numbers. You will have a lot of numbers, but it's fine to sort it because you're going to get an n log n solution anyway. And you have to sort it to be able to actually increase or decrease your distance like optimally. Because if you just have numbers all over the place, you can't do that. But let's say we have sorted numbers. So in fact, let's just say these are our numbers, right? So this. So these are all our numbers. And let's say we're looking for numbers with a distance less than or equal to 5. So you can actually do this in linear time. Like if we're just basically asked like how many numbers have a distance less than or equal to 5. And the way to do that is use a sliding window or a 2-pointer. And we can just say like, okay, let's take an end number and let's make like let's figure out like what's the minimum distance to have that, and then like kind of what we need to do. So let's kind of show what's going to happen here. So we're going to have 2 pointers or like a sliding window where you have a left and a right pointer. And so you're basically going to say, okay, well, given this right pointer, where is the left pointer going to be? Like where can the left pointer be where all the distances closer than that or that are less than or equal to 5? So here, the left pointer will just stay here. And we'll just have no results. Okay. So here, this distance is 1. That means everything this or shorter is going to be valid, and everything outside of this won't be valid. So how many things are there? If the left is here and the right is here, there's actually only 1. It's not right minus left plus 1, it's just right minus left. because you don't want to include a node paired with itself. You have to actually have like different pairs. So here there's one number. Then we move this again and we say like, okay, is this bigger than like, is this bigger than 5? No, it's not. That means everything in this range will be valid. How many things do we have here? We have 2, right? So we have 0, 2 and 1, 2 are going to be our pairs. So that's going to be 3. Then we go over here again. We say, is this valid? Yes, it is. So we have 3 here. So it's 6. This all valid? Yes. So we have 4 here. So 10. Is this all valid? Yes, it is. So we have 5 here. And just to quickly show that, so those pairs are 0, 5, 1, 5, 2, 5, 3, 5, 4, 5. So that's how you have the 5 pairs. Okay. So I think I need, yeah, so I think it's like this. Okay, now here, this is too big. So when the distance is too big, we're going to shrink our left pointer until it's no longer too big. So we're just going to shrink it like this. And then every distance in this range is valid now, right? So we're going to say it ends with a 6 and all of these numbers. So that's 5 more numbers. So we get 20. Then this is too big, so we shrink again. And we're going to keep getting 5 numbers here. So 25. And then same thing here, we shrink again, 30. And the last one, 35. So we have 35 pairs with a distance of less than or equal to 5. So now that we can answer that, given some distance, how many pairs have a distance less than that? Okay, well, what are all the possible distances we can have? So the smallest distance you can have, we'll just say it's 0. And then the biggest distance you can have is just going to be the biggest number minus the smallest number. You can also use the smallest distance as like the second number. No, it's actually not necessarily going to be that. So the easiest thing is to initialize the distance as 0. Because there could be a distance that's... I guess you could find it. Yeah, you could find it. You could compare every number that's next to each other, and then whichever one has the smallest there, that's your answer. Because it's not necessarily going to be like the second one minus the first one, right? Because imagine if this was like 0, 10, 20, 30, 40, something like this. And then here we have like, here we have like 81. The smallest distance is actually here. So you could get it, or you could just say 0 and it'll work out with 0. But then the biggest distance will be, well, you'll know for sure is going to be the biggest number minus the smallest number. So what we can do is, if we have a distance and we can find k points that are less than or equal to that, that means that that distance might be our solution, right? It might be, it might not be. So basically, actually, let's not do it that way. Let's say, so how many points have a distance? Is that number greater than or equal to k? This is really what we want to answer. So with a distance of 5, how many points did we find, and is it greater than k? And I guess maybe there might be some optimization where if it's exactly k, that's probably your answer. We can try that. Right? Because like if we try distance of 5 and there's exactly actually no. That won't be exactly, that won't, you won't always get that exactly, because imagine yeah, so definitely not. Because imagine every number is like a 0. So all your distances will be 0. And then when we plug 0 into our equation, we'll get some big number. And so that number isn't exactly k, but that is our solution. So you can't just say like, if your number isn't k, that's not your answer. So I think maybe still if it is k, it'll work, but that's going to be like more confusing. So the easier way to do it basically is we have our bounds for our distance. And then what we need to do is we can actually just binary search here. So if we try a distance of 5, like let's say we're looking for the third smallest, or let's say the 5th smallest distance, and we try some distance, and we get that there's like 7 pairs that are less than or equal to that. Well, that might be our answer, but then if we try another, like basically which way would we have to go after that, right? So let's say we try a distance of 6, and there's 7 pairs that are less than or equal to that. Well, we know for sure that the answer won't be like 7. anymore, right? Like we know for sure like anything with a bigger than 6 distance won't be the answer, because if we have our distances array and we're looking for the top 5, if there's 7 less than or equal to 6, that means that there's no way it can be bigger than 6, because we're looking for the exact kth one, and if it's bigger than 6, there's going to be more numbers. So basically, if we search for given some distance, if we get greater or equal to pairs that are smaller, we can exclude any bigger distance now. And then we can just try, smaller distance. And so this is going to have like that true false, or that like binary search property where like things are going to be false and then they're going to be true, right? So if we get enough pairs, then we know for sure we don't want to try a bigger distance. But if we don't get enough pairs, like for example, let's say we try a distance of 10 and we only get like 3 pairs and we're looking for 5. We know for sure, like if there's only 3 pairs that are less than or equal to 10, we know for sure we don't want to try like a smaller number, because then it's never going to work, right? Like if there's only 3 pairs with a distance of less than or equal to 10, we know for sure if we try a distance of like 5, there won't be enough. So that's kind of how you can do it. I think that you might have that optimization that I was saying. If it's exactly k, we'll try it and see what happens. I think if it's exactly k, that might work. But if we get less than k, then we know for sure that we have to increase our distance. And if it's greater than k, then that might be our solution. We don't know for sure. But then we can try smaller numbers. Like I said, that would be the case here, right? Like if we're looking for the 5th smallest distance, it is 0, but there's like a bunch of distances here that are 0. So yeah. And so that's kind of the idea. So we're going to binary search all possible distances, and we're going to check how many numbers are less than or equal to that. And then based on that, we're going to know what part of the binary search to get rid of. So hopefully that makes sense, and I think it'll make more sense in the code, but it's definitely kind of tricky because you have to do 2 parts, right? You have to do the binary search, and you also have to figure out in linear time, how do I get all the pairs? Okay, so let's code that then, and then we'll try this k optimization, see if that works. Okay, so first we'll make a function that's going to be our like given a distance, how many pairs, how many pairs do we have that are less than or equal to that? So we'll say like int count pairs. So we need an array to look through, and we need a distance. So we'll have result, left pointer, and then we do a sliding window. Okay. So the idea is basically if our distance is too big, then we need to shrink our window, and then everything in the window is valid. So while left is less than right. Do we need a less than right? I don't think. Yeah, because we can have a distance of 0. Yeah. So we need this, and then if nums right minus nums left is too big, we need to shrink. Okay. Then we're going to add right minus left, not the +1, because we want unique pairs. So if like right and left is the same, we have no pairs. And if left is right before the right, we only have 1 pair, right? If we have like these 2 numbers, this is only 1 pair, this is 0 pairs, and so on. Okay, and then we're going to return the result. So this is how many pairs we have that are less than or equal to distance. Now we can write our binary search. So left will be 0, right will be nums length. Okay, and we also want to sort beforehand. Okay, so we'll try the, and I was using, I started using a binary search template with just less than, left is less than right. You can use an equal, and if this is true, you can set your result to that. Either one's fine, whatever you're comfortable with. So let's try this. So let's get a pivot. Yeah, we have to like not overflow as well, so it's gonna be like right minus And then we want to do, oh yeah, I guess we have to do it this way. Okay, so it's going to be right minus left over 2 plus left. Should work. Okay, so that will make sure we don't overflow. So let's just get like the count. Oh yeah, this needs to be the pivot. So let's get the count of this pivot of this. So let's see what happens if it actually is k. So if count is exactly k, let's just return that right away. Okay. If count is greater than k, so if you use this kind of template, if this is a possible solution, then you want to make your right equals pivot here. Otherwise, you want to try a bigger number, so this, and then return left in this kind of template. Or you could, like I said, you could do this and have the result like I did before. That's fine too. So anytime this is true, just record the result and then make right p minus 1. That would work as well. Okay. Let's see. Might have some errors. Oh, we need to pass nums. Okay. Okay, I guess we got an infinite loop. Okay, let's see. So 113, k is 1. Okay. So I guess we're probably returning here. So let's just print our thing that we tried. Let's add this in. Okay, how do we get, oh, wrong one. Oh, it's this first one, okay. So we tried a distance of 1. Oh, right, that's the problem. Yeah, so you definitely can't do this because you might get like with it. So in here, the answer is actually 0, but 1 also works. But 1 is not in our distances. So like something might be exact here, but then this distance might not exist, right? Like imagine your distances are like 0, 2, 4, or 0, 2, 4, 8, whatever, and then you're trying to find like the third smallest distance, and then you try the number 5. So there will be 3 numbers that are smaller or equal to 5, but there is no 5 in here. So that's why you can't do this. So this is invalid. Yeah, I was thinking, I was pretty sure there was something that would make it fail. Okay, there we go. Let's see what else we're doing wrong. Okay, so we're getting 2 and we expect 0. Okay, now, oh yeah, because we didn't have that case. And this is like this. There we go. Okay. Yeah. And I think that's pretty interesting, like when you do these problems. Ooh. Oh, right. So, this is going to be, if it's smaller, we need to do, yeah, we need to do pivot plus 1. Yeah, okay, there we go. A lot of mistakes. Okay. I think this is good to do where like you try different things and then you see like, okay, I'm thinking of some optimization, will this work? And then figure out like if it does or not. Yeah. Okay, so this is good now. Yeah, I don't think you can improve anymore. Curious what other people did for like better. Well, I mean, it's like all basically the same. So let's see. Yeah, basically the same. Okay, so just some whatever, same thing. Okay, cool. Okay, so so we're sorting our numbers, which is n log n, and then we're doing a binary search based on the biggest distance possible. So this is going to be like the n log the maximum number in the array and the space. Let's see, do we use anything? No. So constant. Okay, that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.